Hey, for anybody who's watching this, thank you. I'm going to go over my capstone defense today. So forgive me as I stumble through my notes and I go through my slide. There's a lot of material to cover. Um, what I believe is kind of the forefront of one of the most important technologies right now, something that is changing every day. But I'll go into it. So hello, I'm Andrew Caprio, and today I'll be presenting reliance under choice, trust calibration in autonomous systems. This project examines how human trust in autonomous system is formed, disrupted, and recalibrated, particularly when people are expected to supervise automation that can act independently, but not perfectly. Today, I want to walk through the full storyline. So the problem, the research approach, what I found, the framework that I believe would be in the best interest of the future of this technology, and why it really matters. So the problem is fundamental tension. So humans remain responsible, but the system is the one acting. This creates a mismatch or an unknown. So between control and accountability or perceived accountability. So as a system becomes more capable, humans rely on that system, and humans also monitor and intervene in that system, but their role becomes less active and more supervisory. This is not just a technical problem. I believe it's a human factors challenge. So the research problem is that automation is often judged by performance, but failures frequently come from misuse. We consistently see over reliance, under reliance, and delayed intervention. Uh, these are not random. I think they're patterns. If something happens more than three times, then these are patterns that can be designed out. So, and they all point back to one issue, and it's a miscalibration of trust and what a trust model, trust design would look like. So why does it matter? The performance does not guarantee proper use. A system is only as good as it is used for. So if a hammer is not used in the correct manner, if you use the end, it is not a good hammer. But it was not designed that way. So trust drives the behavior and the actions of those behaviors. And if trust is misaligned, even high performing systems can be used incorrectly. And these create real world safety risks as we move into a fully customizable, automated world around us. So the scope of my work, the project focused on human trust in autonomous systems through a human factor lens. Uh, it is conceptually cross domain, but grounded in humans interacting with automation, not just how systems perform themselves. That information is largely proprietary. So I did just focus on the human interacting and the human machine trust systems, so human interaction trust systems. The emphasis is on understanding reliance, supervision, and behavior. So the research question is, what drives trust calibration? What cognitive, physiological, and system design factors drive trust calibration? This matters because it's not about liking a system, it's about whether reliance matches actual capability. And it's where you place the human right now. I think if I was to write this next month, it would have been where to place the agentic bot or something like that. But for right now, I'm focusing on the human in this loop. So how the human interacts with the world. So methodology is qualitative in nature, so qualitative synthesis of human factors literature. Uh, what what I included in this was reviewing research across automation and cognition, identifying reoccurring trust related patterns, and integrating those into a framework. It wasn't just a summary of everything that I've read or experienced or worked on, from military to now AI systems in Congress. It was structured and synthesis designed to connect theory with practice. Again, driving what that thing will be used for. So the key insights is pretty neat. Key insight that trust is not static. It is not this like linear model and A equals B in a sense. is extremely dynamic, and it might even dedicate future studies to this, but the dynamics of this, it's continually updated based on experience, and that's not just like, again, we're focusing on the human side, but like it's updated from a software side too, but it's continually updated from a human side. So like the users are constantly adjusting how much they rely on a system or how much they don't rely on a system in the structure, right? And that builds a lot of a lot of information. So so trust is better understood as a process and not a fixed belief that this will be a thing. It's a very dynamic and fluidic. It's a true relationship. So but you have to be able to quantify the unquantifiable and put numbers to things. So what are the core drivers? Like what did I come up with as the core drivers to put these things together? I think there's three for sake of ease and one focus is I think the things that every system should have is it should be cognitively focused, it should be physiological focused, and system design. System design is not last because it's least important. It's last because it's the most dynamic and it's the hardest. These became the foundation for me understanding how trust is formed and adjusted when humans interact with machines or human machine interfacing itself. So, what are the cognitive things? Well, like in the first one we talked about, what is the cognitive focus and cognitive factors? Cognitive factors shape how users interpret the system, right? System is as good as they use it for. So, what is their first interaction? It includes mental models or decision models, and then expectations and perceived capabilities. I want to be very clear on that: perceived capabilities. People don't respond to the system itself; they respond to what they believe it can do, and they either hit that mark or not hit that mark. So they're in that relationship is understanding. It's education, it's belief, it's where it fails. And remember, it's dynamic because it could do something one week, it could not do it the next week, and depending on where in time that relationship has started and stopped. So and even understanding that it is dynamic. And when the belief is wrong, misuse begins. So it's quite a sliding scale. And then moves to the next aspect of physiological factors. Physiological factors shape whether users can actually perform in their role. Fatigue, stress, attention limits the effective supervision, and then also goes into the previous one of how much are down this trust rabbit hole or trust model are they to then allow more fatigue, to then allow those to shape their interaction. That's a very inverse operation there to then move it forward. So even if someone understands the system, they may not be able to respond effectively in a moment. They might have given more control over or less control over, or believe they can be in a lowered state than they are traditionally to then operate or supervise an automated system. So trust is constrained by the human capability itself, not just knowledge, and that's a very human factors interaction. And then the final piece is system design. There's so many things that go out there. I think literally as I record this and present this, that there could very well be a new system design attributes tomorrow. So system design it actively shapes trust, and it's through transparency, feedback timing, and authority clarity. The transparency one is important because as these software updates come out every week, sometimes they actually reduce the amount of transparency or update it and tell you what you can and can't do, or if you're well involved, you know it could do something before that it doesn't do now, which then makes you doubt or understand or move your trust scale to where it is. The system communicates what it can do and what it can't. That's especially if something was changed. Excuse me for a second. Um, if that communication is unclear, trust becomes miscalibrated drastically. So system design is 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 the last on my list, but it is by far some of the most important pieces. Um, and we'll dive more into that. So, critical insights. We built confident systems, not honest ones. So, we build systems that appear confident but are not always honest about their limitations. Repeated success inflates expectations. So it handled this, so it honestly handled the next one. I call this the mirror bias. That this can especially happen when you jump from one automated system to another. I'm actually alluding around the transportation aspects here. So if you're in one system and it goes to the other, that trust model doesn't actually transfer over. But in most humans, it does because, well, why doesn't it do this? My other one does this. So that mirror bias becomes really important. Confidence grows faster than true capability, and so that's why I believe that sometimes you can overinflate this, and that capability mismatch is a huge risk. And over time, I think that that leads to over reliance, and that goes back to that first human, that second human factor of stress fatigue. That you'll enter into a system, and you might not be to the optimal level of what the system designer would say that would be needed for supervision or capability of that. Um, I could realistically talk about hours just for these three things and how they go into to the design and the insights that I've made. So the framework itself, primary result in study is uh, um, the system design, human interpretation, physiological state it moves to trust calibration. So the primary result is the study is the VATC framework. It integrates system design, human interpretation, and physiological state. Trust calibration emerges from the interaction of these three layers that the symphony that you would orchestrate between those flowing amongst each other. And this moves the problem from an isolated variables to like a system level model, uh, which brings me to the trust is a system interaction problem. Trust is not just a human problem or a system problem. It is a system interaction problem. It emerges from how design and interpretation and human state interact over time. Very, very clear on that. So that is where miscalibration occurs and where design really must intervene. It's not just like an isolated failure. So this is I'm a big fan of this word, but this is like the trust continuum. Trust exists on a continuum. Uh, the, just disuse or sorry, disuse uh, on one side is something that happens all the time, right? So miscalibrated misuse on the other, and calibrated trust is in the middle. So you have those who will be malicious and disuse it, like they're going to be there, and then on the other end, like you would have the miscalibration, and that's your mirror bias. It's jumping from one system to another, and that's how the system is designed. And then this trust continuum is somewhere. For ease, I'd like to say like left to right, but it's not. It's more of a of like a wiggly line that goes up and down and left and right, and some things are great, some things are bad. It's so dynamic. I wish I had the artful skills to show of what I really see this squiggly line from left to right really looks like, more like a spaghetti bowl if I would put anything to it. So what are the design implications? So designing for trust calibration means like uh, reducing ambiguity, so like knowing what you're working with, and what is the model that is um, I think that's going after like the humans that are going to be in your loop, and knowing like how they're going to use it. And as that grows, that model will have to grow as well. And aligning mental models, so making sure they batch the system, and I think that would be like some standardization in the mental models, and improving handoffs, so handoffs of when they're interacting, and how they interact, and lead ups and alert systems. So this is where a theory becomes practical design guidance. I really hope one day to be in one of these to maybe work on them, whether that be from where I sit now as legislation side, or maybe in the future. But yeah, so what's the industry impact, and why the hell does this matter to industry? It's because trust must be designed. It just can't inherently be assumed. And like it's America is the only country that is buyer beware. In the rest of the world, as you globalize autonomy, like there should be real hard intentionality set for how trust is designed in interaction with these systems. It affects safety and critical systems, and real world outcomes happen because you now are taking large large ecosystems of things, and removing the human from the day to day operation. So when they do fail, the failures are catastrophic. And if trust is wrong, performance doesn't matter. It'll handle things in one way or another. So what are like the challenges and limitation of this is the my research is interdisciplinary, and trust is defined differently across fields. So I keep alluding to this fact of like finding some standardization across these, which unfortunately only happens when catastrophic things occur. So I would have to forecast a future state where this does happen. It's also a conceptual framework. It's not experimentally validated yet, so I don't exist in this. This is a $1 billion industry, and people are unwilling to let others in for this. So I can make these remarks and things, but it's very much on the edge of what it can be interactive. And finally, this creates an opportunity for future work. So like what will align and what will go in. So like what were like the program outcomes and how to like align with it. This project uh, is integrating theory with practice. It applies systems thinking and human factors principles to a complex problem that is ever changing every day. And the deeper I go down this rabbit hole, the more I find, the more I discover. And it's consumed my life the last bit. And it demonstrates how research can translate into real world design implications. Like these problems are known and they've existed from the beginning of aircraft aviation to automated missile systems that are driven on performance and transparency for fuel costs and performance, to now these integrated human models where transport is perceived on trust and allowance for the system to be used, all the way to applications on your phone that remove um, uh, bad tasks from your day to day. So this is something that has been around and it has been studied. So now we're seeing final applications, not final, sorry. Now we're seeing applications of this in the day to day, and it's growing faster and faster. I believe this applied human factors, and it's awesome. I'm so happy and grateful for this opportunity to be able to go through it. So, what are my key takeaways? Like you're not smart in the systems. You really need to learn. We don't need smarter systems. We need people to understand them and have trust. We need systems that shape human behavior correctly over time. And I think in that VATC model, it's like an integrated approach for how many touch points, the frequency of touch points. I really wish that I could work with this a software team, our company, to then design that and have actual numbers for like what that looks like. And then autonomy succeeds or fails based on how humans understand and interact with it. That's any system, that's any tool. So it's what our perceived current trust and application ability, what are past notion points, where are anchors for understanding. I think that's it. So like better human system alignment is like key, and then trust finally at the end of the day um, is what determines success. And I hope, or I forecast that the trust models and trust complexity in human machine interfacing is only going to grow. It's only going to be used and tracked, and again, quantifying the unquantifiable, putting numbers to things and measuring things that once we never had the opportunity to place the aggregate towards, or just to sorry to investigate the aggregate, which now is becoming readily accessible. So overall, I just can't say thank you enough. Thank you to the school for letting me to research this, for the professors who have taken my ridiculous work schedule and what I do into effect, and allowing me to take the time to record this. If you can't tell, I'm trying to slow down my passion on this a little bit. There's a lot of things in here that I could talk about for hours and whiteboard and run strategy for. And I try to narrow down my passions to the things that kind of matter in this. And just thank you, thank you, thank you. Please, if you're listening to this or reading this, email me questions, andrew.caprio 973 at gmail.com. I would love to talk about this more. I would love to have phone calls about this. I would love to sit in on classes in areas where people are studying trust models and loops and integration and automation in the future. So, like, truly, thank you. And I really look forward to future questions. And I am kind of sad that I'm closing this out, but I look forward to furthering these studies and learning more about what this is. So thank you.